Alright, hello everybody. Today's problem is going to be a simple one. This one is simply called check if a tree is symmetrical. This is going to be specifically talking about a binary tree if I didn't clarify that. So it's more of check if a binary tree is symmetrical. So first let's get an understanding of what this problem is asking for. What does the word symmetrical mean in this context? So let's switch. So I'm sure you guys all know by now what a binary tree looks like, but you have a root node, and then from it you'd have two branching nodes. Now for example, if the root node had a single value of 1 and both of these were the same value, this is not a binary search tree, this is a binary tree, just a binary tree with a single node connected to two different a parent node with two child nodes, meaning that is a binary tree. This is considered a symmetrical tree because you can see like the left half and the right half are exactly the same. However, if we were to add like 1 here, this would no longer be symmetrical. We would need to have 1 here. If we added another 1 here, to counteract this, we'd need to have another one over here, and so forth and so forth. Also, the values have to be identical on the left side and the right side. So if this was like, for example, a different number, like let's say this was just 1 or something like that, then this wouldn't be a valid symmetrical tree. So with that in mind, let's take a look of what key features we could see in this tree that particularly makes it a symmetrical tree. So we know that on the left half, when we're taking the left half of the tree, what we call these halves of the tree is the subtrees. So you see there's this root node, and each node has its own individual left subtree and right subtree. So at first, you might want to think, oh, it's as simple as saying that the left subtree and the right subtree are exactly equal. And while that's a good place to start, it's a little bit more complex like that, because as we can see here, they're not exactly equal. 3 has a left node, whereas this 3 has a right node sticking out. So a valid way to probably explain this is that the values correspond at their particular mirror positions. So, for example, if the left subtree has a left node, the right subtree has to have an equivalent right node. Whereas if the left subtree has a specific right node, that the right subtree has to have a particular left node. So that was a little bit of a washed explanation, but hopefully we can start getting into the code and you guys will get a better explanation of what exactly I mean here. Alright, so let's switch to our code real quick. So I already defined the tree class. Let's start by creating the function def is symmetric, and all we need in this function is just the root node. So let's just say root. Now in this function we are going to call another recursive function, and you'll understand why we need this later, but we'll have this def is mirror, and then we're going to have two elements here, t1 and t2. And what t1 and t2 are essentially the left subtree and the right subtree. So remember in the explanation I was giving earlier about how each tree in a binary tree, each node in a binary tree has its own left subtree and right subtree? That's what T1 and T2 are going to be representing here. So now let's take the base cases. So first, what happens if there's no left subtree and there's no right subtree? So we can define this by saying if not T1 and not T2, I return true. The reason we're going to be returning true here is if not T1 and not T2. That means both the left subtree and the right subtree doesn't exist. So if we could see that in the whiteboard, if both of these things didn't exist, all we would be left with is this root node right here, right? You'd only be left with this root node. And since it's just one node, this one node is obviously just going to be symmetrical because there's no left side and right side. So it's just a standalone node at its own, and it's just going to be considered symmetrical by default. So we're going to be returning true if not T1 and not T2. But then what is the alternative? The alternative is that if not T1 or not T2, return false. And what this means, so if you guys remember what the OR boolean means in Python or any coding language, OR means that if one of these things is true, you're just going to be returning true. So this means that if T1 doesn't exist or T2 doesn't exist, return false. Why is that? Because if one we can go back to the whiteboard to explain it. It's getting really messy here, but let's see if I can erase it a little bit. So you see this node? If T1 or T2, so T1 is a left subtree and T2 is the right subtree, right? If one of these didn't exist, so if one of these didn't exist, that means the tree is no longer symmetrical. This is no longer a symmetric tree. So therefore, this one, where we're saying if not T1 or not 2, we would be returning false there. Now, those are the two essential cases we need to know. Now, what else? We need to return true if, first of all, we need to make sure that the t1.val is equal to t2.val. That is one thing we need to make sure. We're going to have three different conditions here. So the first thing we need to make sure is that all the values in the subtree are identical. So the T1 subtree value and the T2 subtree value. This one, you'll see that T1 and T2, in this problem, we're considering them as their entire subtrees. But when we're looping through this thing recursively, we're going to be seeing that T1 and T2 are corresponding to particular nodes in the tree. So these are both tree nodes that are nodes that are taken as parameters. So we need to make sure that those node values are the same, and we need to see is mirror. This is where we're going to call the function symmetrically. Is mirror of t1.left comma t2.right and is mirror of t1.right comma t2.left. So this is a lot, but we can go through this step by step as fast as possible since we're actually starting to run out of time. But essentially, remember how we were initially talking about how a symmetrical tree works? So you have this node here. If this one is a right node, you have to make sure that the left node is the same. And on this left subtree, if there's a right node, you need to make sure that there's a left node to match. So this is where it goes back to here. We need to make sure that we're calling this function recursively on the left subtree and the right subtree, and then you have to confirm that, as well as making sure that the left subtree's right node is equal to the right subtree's left node. And you have to do so. Trying to summarize this again. The left subtree's left node is equal to the right subtree's right node, and the left subtree's right node is equal to the right subtree's left node. You see, left subtree's right node is equal to the right subtree's left node. The left subtree's left node is equal to the right subtree's right node. So that's essentially what we're doing here with these recursive statements. We're continuously checking to make sure that all of these values are true, and if all of these are true, then it'll return true, otherwise it'll return false. So at the end of this function, this is a helper function, we can just return the value of this helper function of root comma root. In this case, we're starting with just the root node, so we can have both of the t1 and t2 values, which are meant to be the left and right subtrees, be root and root to start off with. And yeah, that's pretty much it. Now we should let's test the code. I'm going to create a sample tree here. So this one has a root of 1. Root.left is 2, and then it's going to have 3 and 4. And this one is going to have 2, and then 4, and then 3. So if we draw this tree out, it's going to be like 1, and then root.left is 2, and then 3, 4, and then this one is going to be 2, and then 4, 3. It's a little bit different than the format we had when previously making these things, but this is essentially what the tree is going to be looking like. And essentially, as you guys can see, this is a symmetric tree. So when we run this code, we should get an output of true. Let's run this code. Oh, shoot, sorry, my bad. I forgot to print it. I printed out the value. Is symmetric of root. And we get the value of true. And we can just change one value real quick. Like let's say this one is 5. And then once we test this, we'll get false because the tree is no longer symmetric anymore. So yeah, essentially that's how this code works. Hopefully you guys understood my explanation there. And yeah, that's how you'd solve this is symmetric problem by checking if a binary tree is symmetric. Alright, see ya.